Thank you for joining us in this video. My name is Julio Perez, and today we'll be going over how to define connected endpoints and look at a more efficient way to describe our connected endpoints using port profiles. Port profiles allow us to reduce the repetitive input when defining an endpoint. We have a reasonably small topology for this example, one spine and two leaf nodes. We then have three hosts connected to leaf 1. Host 3 is connected to leaf 1 and 2, forming an MLAG pair. When looking at a new feature or trying to find out how do I define a thing, I usually go straight to documentation. So in this case, this is the avd.arista.com website. And for this portion, connected endpoints, this is an EOS designs construct to define how our endpoints are connected to the fabric. So in this case, under roles documentation within EOS designs, I'm under the input variables section. And within input variables, I'm in the connected endpoints settings. Now with connected endpoints, we have two data models that are available. One, connected endpoints, and two, network ports. We'll actually be going over network ports in a future video, so we'll save that for now. But connected endpoints allows us to say, what leaf is my node connected to? What connection am I using from this host? In this case, I will show you some of the keys that are available, and we'll also see these in the examples. So for example, when defining connected endpoints, we have the ability to use a key of servers, firewalls, routers, so on and so forth. This can be leveraged to organize your endpoints into logical groupings for your host, depending on their use case. Now, if you wanted to start off, or you're just getting started with AVD, you might see examples where everything's just leveraged something like generic devices or all under servers, which would be fine. But later on, as you use AVD more and more, it might be helpful to split out your hosts or endpoints into different keys. And just be mindful that these are just the keys that are built into AVD. You can also define your own connected endpoint keys. For this example, we'll be using the built-in keys. Now, if you're on the site, if you scroll down just a little bit, not only do we have the data model that encompasses all of the features that are available with connected endpoints, but there's also built-in examples. So for example, an example with profiles, as you can see here, there's examples with a single attached host, a dual attached host. So in this case, I won't go over every single key within connected endpoints, but as you can see here, we have a high-level option of connected endpoints keys.key. So that would be the keys that we just saw above, like servers, generic devices, access points, so on and so forth. Then we have a rack. Now this is more informational, which would be useful in the documentation that AVD will generate. Then we have adapters, and you might notice that adapters is actually a list of adapters. So a node could have more than one adapter. Within adapters, there are three keys that must be defined: switch ports, switches, and endpoint ports. If you notice, adapters can also be a list of adapters, and within switch ports, it could be a list of switch ports. So for example, a connection or a definition for an endpoint could have multiple switch ports that it's connecting to. And same thing with switches, we can connect to more than one switch or have multiple connections to the same switch. And then the last one for endpoint ports, that's just what ports is my endpoint using to connect to a specific switch port. And again, this could be a list of endpoint ports. Now, the data model is very extensive, anything from speed to VLAN, spanning tree settings, point-to-point, 802.1x, so on and so forth. I mean, it's very, very comprehensive, and all of these keys can be defined under the adapters settings. Now I'll flip over to the code editor where we're running AVD and have our basic AVD topology defined and created, and we'll go over the connected endpoints constructs. In this example, I'm leveraging Ansible AVD, and here on the left, we can see a series of group vars, my endpoints.yaml, fabric.yaml, lab.yaml, fairly common build out that you may see in a lot of Ansible AVD examples. And in this case here, I'm defining how my endpoints are connected within this endpoints.yaml file. Now, if you notice, I am using different keys. So in some examples, you might see servers and then a list of different endpoints under servers. But in this case, I wanted to show you the flexibility of using different keys. So in this case, I'm using generic devices for host 1. For printers, I have host 2. And then for servers, I have host 3, which in this case is an example of defining a host that's connected to more than one leaf node. So in this example, we have endpoint ports of Ethernet 1, Ethernet 2. Again, this part is only used for documentation. And then we have switch ports of Ethernet 4 and Ethernet 4. But this ties into the switches key of leaf 1 and leaf 2. So if you read this vertically, you can see that Ethernet 1 on this endpoint is connected to switch port Ethernet 4 on leaf 1. So think of that as how it vertically stacks to know where something is connected to. And in this case, this one's a little bit more extensive. We have a description of VM. So there's actually a default description that will be created by AVD. But in this case, we want to override the description because it's one of the keys we can leverage for the connected endpoints data model. Then we're setting the mode to trunk, VLANs to 112, and it's a port channel in active mode. But in the first two nodes, you can see that in this case, there's a lot of duplication in the definitions of these two hosts. So for example, we have the three keys that we have to define in endpoint ports, switch ports, and switches. So those have to be unique and those have to be within adapters. But there's two pieces here that are now starting to get duplicated. So in this example, we have host 1 and host 2 are both, they need to be access ports, and they're also assigned to VLAN 110. So yes, this is only for two devices, but just imagine when you have 50, 100, or even more devices defined or endpoints defined. Well, this is only going to increase the amount of input required from the operator or through some automated solution to define a connected endpoint. Now, this is where port profiles can be leveraged to lessen the burden of the input required by us. So in this case, I'll scroll up a little bit. I cheated a little bit and I already have some of the port profiles, or realistically all of the port profiles we'll use in this example defined. So in this case, we have a top level key called port profiles. And then I just have a list of profiles. So here we can see I have my first profile called access mode, and it's just setting the mode of access in this profile. But something that's interesting and where you can see the inheritance is that we have another profile called data. Again, just a generic port profile here, but it has a parent profile of access mode. And in this case, it's using VLAN 110. So what's going to happen is that any adapter that's assigned to the profile of data will be assigned to VLAN 110, but since we are leveraging parent profile of access mode, it would also get the access or mode of access inherited in its port configuration. So in this case, let's test this out. I will change the host 1 and 2. Instead of defining mode and VLANs manually, I will remove that step and then assign the profile of data to both of these endpoints and then run a build. Okay, let's see what happened. So in this case, you can see that I've redefined the adapter configuration for host 1 and 2. So in this case, I removed the mode and the VLAN it's assigned, but I assigned a new key of profile to data to both host 1 and 2. And here, if we look at our git diff, we can see that the updates that were made by myself, and then when we run a build, we actually get updates to the structure configuration. So in this case, now it's specifying that the port profile of data is assigned to this peer, for example. But in this case, for leaf 1, the configurations essentially inheriting the exact same thing hasn't changed. So the host 1 configuration is still an access VLAN 110 and it's in mode access. Same thing with Ethernet 2 for host 2 with VLAN 110 and mode access. And then Ethernet 4, there's no change with the VM that's in a channel group. But now that's one step of how port profiles can be useful. But if you notice, at least in our servers, so in this case, host 3 is playing as our little test server here. And we have multiple endpoints, multiple switch ports, multiple switches, but there's more defined, right? There's a description, there's a mode, there's VLANs, a port channel. Now, again, this is only one server, but now you're adding 10, 20, 30, 40 servers, all with a similar construct or similar VLAN, VLAN allowed definitions. This can get kind of tedious and it's going to be very long-winded definition. So in this case, we also have a profile called VM that's essentially using the exact same keys that we've already using in our port profile definition, or our adapter definition. So in this case, we have a description of VM, we have a mode of trunk, we have a VLAN 112, and a port channel mode active. Now in this case, we can rewrite the definition of this host 3 adapter to leverage this profile. So in this case, I'm just going to remove all of the settings, and then I'm going to assign it to the profile of VM. Again, I'm going to save that, and then I'll rerun a build, and we'll see that, yes, there is a change, and now we have a new profile, but the end state of this server would be exactly the same. Okay, so once again in our git diff, let's look at leaf1.yaml. We can see that now this interface is going to be assigned the port profile of VM. Nothing different there. And then leaf2, same thing with now the, the peer, the connected endpoint of host 3 is going to have the port profile of VM. But within the leaf1 config or in the leaf2 configuration for that VM or our test little sample VM here, it hasn't changed, right? All that inheritance is all still the same, but we've reduced the amount that we need to define for this VM, or in this case, host 3, down to just leveraging the profile. So you could imagine if you had a whole slew of VMs using the same port profile and you needed to make a change, for example, maybe an allowed VLAN or updating the VLANs list, you'd only have to make it within the port profile. So very powerful feature. Thank you so much for tuning into this short video on connected endpoints and port profiles. We hope you learned a little bit about AVD and these features, and we'll see you in the next video.